Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for generating the letter combination of a phone number. Let's look at the problem description. We are given a string containing digits from 2 to 9 and we have to return all possible letter combinations that the number could represent. And we can return the answer in any order. And the mapping between the digit to a character is given in this picture. So here for the digit 2, the possible characters are A, B, C. For 3, D, E, F. So in addition to this digits, we have this input also, which has the mapping between the digits to the character list. We have to create a data structure that holds this information so that we can use this in our program. Let's take a look at the first example. We have the digit string has two digits, 2 and 3. The 2 has 3 possible characters A, B, C, and 3 has 3 possible characters D, E, F. So in order to form combinations with these 6 characters, there are 3 ways we can choose a character from this and 3 ways to choose character from this. So as per the basic combinatorics product rule, so total number of combinations that we can generate out of these two sets is the product of the choices we have and the choices we have. So in this case 3 times 3, 9. So we get totally 9 combinations. If you look at it, first we take the letter A and add D, one combination. Take letter A, add E, second. Take letter A, add F, third. Same way B, D, B, E, B, F, C, D, C, E, C, F. So totally we get 9 combinations. If the input string is empty, then we have to return an empty output list. If the digits has single digit, then we have to just return the characters that are mapped to that particular digit. In this case, ABC for the digit 2. So the digits length is ranging from 0 to 4 and each digit is in the range between 2 and 9. We have the digit string 2, 3. And then we also have a digit to char mapping. For each digit, what are the possible characters we can choose. Okay. So for this case, as I explained earlier, totally we get 9 combinations. Okay, let's see how we can come up with an algorithm to generate this output. So we initialize the slate to empty slice, byte slice, and then we have an index to track the number of digits we processed in the input string. As we process each digit, we add each character once and then increment the index so that we take one of the characters for the next digit and add one at a time to form a multiple that many number of combinations. For example, first we add A and then we increment 1 so that we get one of the characters from the digit 3 once, and again the second character for the digit 3, third character for the digit 3. Same way here for the B, we are adding one of the first character from the digit 3, we are adding second character from the digit 3, third character from the digit 3. At the end, we convert these individual slices into a string and we generate that output. So we get that 9 combinations. If we rotate this flow 90-degree clockwise direction, we get a tree. We are generating that combinations in a hierarchical fashion. So at the root level, the slate is empty. Then we are adding the first digit in the level 1, the second digit in the level 2. Okay. The level 1, we add one character at a time, and then we go down one level and take one of the characters for that particular digit, in this case 3, D, E, F. So when the data generation is done hierarchically, we can use a recursion to achieve the output. Okay. So basically this is a combinatorial enumeration problem. So those kind of problems can be solved using recursion. Let's see how we can do that. First we initialize the index 0 so that it points to the first digit in the input string. Okay, so this will keep track of the digits processed so far. So whenever we go down one level, that index will be incremented. And also when we go down one level, for each possible characters, we add one of the characters to the slate and then make another recursive call so that we can add the next digits possible characters. So we keep going until we reach the last digit. If we see the last digit, for example, in our case it is only 2 digit. So this is when we process the first digit, this is when we process the second digit. So the moment we see the last digit, we convert this slice into a string and add it to the out list. So here if you see, we have 9 combinations present in the leaf node. So when in the recursion, we can use this as a base case. So whenever we hit the last digits of the input string, we can convert the slice into a string and add it to the out list. Let's look at the flowchart. Input for this procedure is the digit string, the digit to character map, and then the index that tracks the current digit being processed in the input string, and then the slate which contains the partial output, and the out list which contains the final list of combinations. So when we enter this procedure, first we get the list of characters for the current digit pointed by this IDX from the digit to char map. Okay, so once we get that character list, we check whether the current digit is the last digit in the input string. If yes, we add the characters from the char list one at a time to the slate and convert that slate into a string and add it to the out list. We keep repeating until all the characters in that char list is processed. Once that is done, we return that out list. If the digit being processed is not the last digit, then we will make a recursive call for each character in the character list. So first we add that character in the character list to the slate and increment the index so that in the next level we will pick up one of the characters from the next digit. Okay, and make the recursive call. And once for each character in the char list, we make one recursive call, and all the recursive calls are returned back. Then we return the out list. Let's move on to coding. The digits to character mapping is given in this picture. Now I am going to build a map data structure. It's called digits to char, which is a map of byte to a byte slice. Next I initialize the output list with empty slice of string and slate with empty slice of bytes. and index is initialized with 0. Then I check whether the input string is empty. If so, return empty list, output list. Otherwise, make a call to the helper function that takes input string and then the map and then the index and the slate and the output list. And I return the output list. Next, I'm going to implement the helper function. Next, I read the current digit being processed using the IDX pointer, and then I get the character list for that digit. Next, I check whether the current digit is the last digit in the input string. In that case, I iterate over all the characters in the char list and add them to the slate and convert it into a string and add it to the final output list. I convert the slate after adding the current character. Then I return. Next, I iterate over the character list and then make a recursive call for each character in that list. So now when I make the recursive call, I increment the index by 1 so that the next character and the combinations will be picked up from the one of the characters in the next digit. And then I add the current character to the slate and pass it as the new slate. And then I pass the output list. Then finally I return back. Next I'm going to run the test cases. I missed the range keyword. Okay, all the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. So we have the input string that has 2 digits, 2, 3. The expected output is these 9 combinations. In addition to this digit string, we have the digit to char map also, so which contains digits to possible characters that we can choose from for generating the combination. So first, the letter combination functions build that the map, and then I initialize the output list, and the slate is just initialized with the empty byte slice, and the index is set to 0 to point to the first character in the input string 2. Okay, then we check then I check whether the digit is empty. In this case it is not, so I make a call with the digits and then the digits to char map and the current IDX which is 0 and the current slate which is empty slice and the output list. Right now it is empty. So that is what I am depicting in this picture. So when I am in this function, this is empty, the slate is empty, this output is empty, index is 0. When this function is called, inside that function, first thing I do is getting the character list for the current digit which is pointed by the IDX pointer in the digit string. So in this case it is 2, so the char list have A, B, C, and then I check whether this digit is a last digit of the input string. In this case it is not, this is the first digit. Next I iterate over the characters in the character list, and for each character I add that to the slate, and then I increment the index so that one of then in the next possible characters picked up will be from the next digit in the input string. Because we are using the same slate but only adding this character, right? So if we update the slate before making call to this recursive function, then we will have to restore it after the call is returned. So the code will not be readable. So that's why I just pass the return value of this append function as an argument to this recursive call instead of updating the slate variable. Okay, same thing for the index also, idx also. Okay, so if we in case if you want to increment before, then you have to decrement after calling these functions, which we do not want to do. Instead we can, the new values we can pass it as an argument. Okay, so if you look at it in the iteration 0, I added the letter A from this list, and then I increment the idx to 1 and then make the recursive call. So this the from here we make here I make another call. Okay, so when this function is called, the index is now 1, which points to the digit 3 in the input string. So for that the possible characters are DEF. Okay, and here I check whether we are processing the last digit. In this case it is true because the index is right now 1. The length of the digit string is 2, so 2 minus 1 1, so this condition is true. So in that case what I do is I iterate over the character list, and for each character I add it to the slate and convert that new slate value into a string and add it to the out list. Okay, so for on iteration 0 I add D. So the slate already has A, so I add D. So if I convert this into a string and add it to the out list, so the out list will have only one combination after the iteration 0. And then on iteration 1 I pick up the letter E from this character list. From this character list I pick up E. So I add it to the slate and then convert that new slate value into a string and add it to the out list. So now I have AE. Next I added F to the slate and I convert that into a string. So now the out list have AE, AD, AE, AF, these three values. Similarly, and then after this the character list is processed, I return immediately back to the frame 1. So in the frame 1 we are in this loop, so which picks up the next character from the char list, which is B. So that's what I'm showing here. When we make this call, this time for B this loop will be executing. So we add all possible combinations which starts with B will be generated in this case. So that's why I just show it here as B, D, B, E, B, F. Similarly, after the iteration 2, we have C, D, C, E, C, F. Once this is completed, then we return back to the frame 0, which is the letter combination function. Finally, we have the expected output list AD, AE, AF, and all the 9 combinations. Next, I'm going to do the time and space complexity analysis for this solution. Let's look at the different cases of input. In any case, the total number of combinations that we can generate is the product of the choices for each digit in the input string. Okay, let's look at each case one at a time. So in this case, the digit 2 and 3. Okay, so the digit 2 has A, B, C characters mapped to it. Digit 3, D, E, F. Okay, so they have each 3 characters. So the total number of combinations we get is 3 times 3. Okay, if we generalize that, it will be 3 to the power n. N is the length of the input string. If we have another 2 or 3, then it will be multiplied each time that digit occurs in the input string. Okay, so in general, for the string of length n, and if those each digit has maximum 3 characters mapped to it, then in that case it will be order of 3 power n combinations we have to generate. For the case 2, where the digits 7 and 9 each have 4 characters mapped to it, so the total combinations we get is 16. So that's 4 times 4. In general, it is order of 4 to the power n. Okay, so next the case 3 is the combination of 3, the digit with the 3 characters and digit with the 4 character. So in this case, it is 4. Okay, so in this case we have a 12 combinations, because for digit 3 we have 3 choices and digit 9 we have 4 choices. So totally we have 12 combinations. So if we generalize this, the time complexity, it will be order of the product of choices each digit in the input has. But let's take the worst case thing. Okay, assuming the input string has the digits with 4 letter mapped to it, and all the digits are either one of these 7 or 9. In that case, the time complexity is 4 to the power n. Okay, so basically this algorithm is an exponential time complexity algorithm, because we have to come up with all possible combinations. So with respect to the space complexity, it is order of n. The reason is we need to store the partial combinations in the slate data structure. When we reach the end of the input string, at that time we need a space which is equal to the length of the input string for the slate data structure. So the space complexity is order of n. Thanks for watching this video. Have a great day.